Good afternoon, class. We're on to grade 9 mathematics and we're treating number-based system. Our textbook of reference, again, is our essential mathematics for grade 9, and we trust that we'll be able to do quite some good job today. Just a quick reminder, I've also sent you a video. It's always tagged grade 10. It's actually a revision of the just concluded Rivers State basic education certificate examination, and it's from 31 to 60. 31 to 60. So please go through the videos and you'll see why those answers were that way. I also made an adjustment. Question 60, the option to question 60 is not A. I think the option should be E, -14. I think that was an error on my part. The question said what must be added to 74 to make it 60. The only way you can add a number to 74 to drop its value is to add a negative number. So please take note of that correction. And if you had scored yourself wrong there before, check and perhaps score yourself right. But if you have scored yourself right before, check and score yourself wrong. Right? So the reason for that you will see when you watch that video. So, but all right. Number-based system, converting other bases to what? Base 10. And that is seen in our exercise 1.4. So we're converting other bases to base 10. Let's look at number 1. 107 base 8. When you're converting from other bases to base 10, we use what is called the expansion approach. What I call it, the expansion approach. So that will mean you start by assigning numbers in an increasing left-hand direction. You assign numbers in an increasing left-hand direction. So this will be 0, 1, 2. The number you are assigning will start from what? 0. So this will now be equal to 1 times the base raised to the power of the number assigned there plus 0 times the base raised to the power assigned there plus 7 times the base raised to the power of the number assigned there. Are you seeing that? Are we seeing that? All right, so what does this give you? This will give you 64 plus, now this is 0. And I wouldn't waste my time writing 0. It's 0 plus what? Okay, let's just put 0 for the purpose of learning. Plus 7. Anything raised to the power of 0 is what? 1. So it will be 7 times 1, and that will give you what? 7. So when you add this, this will now be what? 71 base 10. Anytime we don't indicate the base, it means it is what? Base 10. All right. Let's try to look at question 2. In question 2, you're given 231 base 5. So what's the first thing you do? you assign digits in a leftward direction, or index in a leftward direction, and this will be what? 2 the base times what? 5 raised to what power? 2 plus 3 times 5 raised to the power of what? 1 plus 1 times 5 raised to the power of 0. Let me go a little gradually here. This will be what? 2 times 25. I'll close in a bracket plus 3 times 5. I'll close in another bracket plus 1 times 1. Because we know that anything raised to the power of 0 is what? 1. Anything raised to the power of 0 will be 1. So that's understood. This will now be what? 50 plus 15 plus 1. And when we add all of this together, we're going to get 66 in base 10. I don't need to put base 10 there because the standard practice is that once the base is not indicated, we assume it to be base 10. Okay, so that's for question 1 and that's for question 2. Okay, so question 3. In question 3, we have 5, 3, 2, base 9. So the first thing to do is to assign indices or index in a leftward direction. Once you've done that, this will now be 5 times 9 to the power of 2, the base concerned, plus 3 times 9 to the power of 1, plus 2 times 9 to the power of 0. Just note that any one that's to the power of 0 is 1. And this will give me 5 times 81. I'm placing in a bracket so I don't forget, plus 3 times 9, plus 2 times 1. I seen that. This will give me 405 plus 27 plus 2. So when I add all of these together, I can use my old school approach so that I don't make a mistake. 9 plus, that will give me 4, carry of 1, 3. So my answer becomes 434 base 10. Now, in reading this number, let me draw your attention to something here. This is not 532. 532 only exists in base 10. So how do we read this? It is 532 base 9. When you're reading in bases other than base 10, we read each digit as a single number. So this is 532 base 9. Right. Okay, so that's for question 3. So for question 4, this is what you have. Okay. So this is 21, 22, 49. Question 5. Base 8. 8 cube is 8 cube is 8 cube will be 64 times 8. That will be 512 plus 2 times 64 plus 40 plus what's there again? 6. So times 3. So let's try to simplify that one out. Okay, so now look at this. This is 1536 plus 128 plus 46. That will give me 12, 14, that's 0. Carry 2, carry 1. So that's what you should have. So with that, I think you should be able to handle the remaining questions now. With these 5 questions we've solved, you should be able to, on your own, handle from question 6 to question 15. Right? So that said, I'm going to give you a minute or two to settle down. Then I'll come back to exercise 1.3. So far, we've learned how to convert from base 10 to other bases. We also learned how to convert from other bases to base 10. What about if we are asked to convert between bases? If you are asked to convert between bases, how do you do that? So converting from one base to another other than base 10. Let's assume you are told to convert from base 5 to base 3. How would you do that? You can't directly convert from base 5 to base 3. What you can do is to start with base 5, go to base 10, and then come back to base 3. So if you're converting between bases, you must convert to base 10 first. If you're asked to convert between bases, you must convert to base 10 first. So that is base X to base 10 to base Y. You must get to base 10 before you move to base Y. So let that one sink. So you already know how to convert to base 10. You already know how to convert from base 10 to another base. Now, how do you move from one base to another? So this is what we will be trying to handle in this exercise. Now, to help us with this exercise, I want us to go to exercise 1.5. Exercise 1.5. So let's start off. Exercise 1.5. I'll look at question number 5. Exercise 1.5, question 5. Question 5 will help us deal with this concept. Now, in question 5, it says A, convert 110 base 2 to base 7. So we have to convert this to base 7. First of all, we need to convert, we need to move this to base 10. Now, when you're converting to base 10, what are you doing? You are expanding. That's the concept you must remember. You are expanding. So that's a key word you must remember. When you're moving from other bases to base 10, you are expanding. So how do we expand? Leftwise observation. And this will give me what? 1 times 2 raised to the power of 4 plus 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. Now, these ones are going to be 0. When 0 multiplies 0, you get 0. So don't waste your time writing them. This will now be what? 16 plus 4 plus 2. These ones that will give you 0. Waste your time writing them. Because we know by mathematics that when 0 multiplies any number, that number automatically becomes what? 0. So we don't need to waste our time on those ones. And when we add all of this, we're going to get 22 base 10. Now, we will now move this from base 10 to base 7. So you will now move this to base 7. And what is the code here? It is what? Division, long division. So that's the code you must remember. You must know where you are to expand and where you are to do long division. Right? So that said, we will then rule this 22 and 7. 7 into 22 will give you what? 3. Remainder what? 2. 7 into 3 will give you what? 0. Remainder 3. You read upwards, and the answer will be what? 3, 2 base 7. So you come again and tell us that 101102 is equal to what? 3, 2 base 7. That's all. So we look at question 5B and let's see how that answer. Now, the first thing is to convert this to what? Base 10. And that will be expansion. So all these ones having 0, I can neglect them. So this will be 1. So these ones will be 0. So I'll focus on this will be 64 plus 4 plus 2 plus 1. 71 base 10. This will be 71. If I've done my maths correctly, that should give me 71. So, we'll now convert 71 to what? To base 8. 71 to base 8. How would that be done? Now look at this. It means we're going to use long division. Remember I told you that there are codes you need to remember. There are codes you need to remember. So with that in place, 8 into this will give me what? 8 into this will give me what? will give me 8, remainder what? 7. I'm right with that. And then 8 into 8 will give me 0, 1, remainder 0. And 8 into 1 will give me 0, remainder 1. So I read from bottom to top, and that will be 1, 7 base 8. So it means that 1, 0, 0, 0, 1, 1, 1 base 2 will be equal to 1, 0, 7 base 8. That's how it is done.